Hi to all. I'm going to cover the subject tools for real-time data processing and analytics in this video. Myself, Dr. V. Sirunmani Sharimila, Associate Professor, Department of ECE, SRMISD, Katangalattur. So the Unit 1 is about Introduction to Real-Time Data Processing. There are totally 5 topics are there, of which the first 4 topics, that is overview, characteristic of real-time, use cases of real-time, and the real-time data processing tools will be covered in this video. Let us see what is the overview of real-time data processing. So real-time data processing is the continuous collection. We have to see the words right. Continuously data is flowing and we are going to collect it. Continuously we are going to process it and analyze it, give a report immediately after it is generated. So no further delay is allowed. No decisions or actions can be allowed afterwards. Everything you want to take it immediately and give it off. And that is what is real-time data processing. So unlike this is what is just opposite of the previous batch processing where the data is processed at scheduled intervals, whereas real-time data processing handles the data as it arrives, fresh, it finishes off the work. What is the working principle behind this real-time data processing is data is generated by sources such as sensors, IoT devices, websites and mobile applications, and then the data is transmitted through a communication network, because once the data gets generated, how it has to reach any app or how it has to reach the server only through the communication network, which is nothing but your internet. Then a stream processing engine, since huge amount of data gets flowed, right? The stream processing engine is required to process the data and to give an alert about the data. Then the process information is stored or visualized. Alerts, reports, or automated actions are generated. Let us see the characteristics of real-time data. The totally 8 characteristics are there. The first one is the low latency. The data must be processed within milliseconds or seconds. No further delay, not even even 1 minute or half a minute is also not allowed. So example is credit card fraud detection. The moment you raise a complaint, immediately it has to be processed, because any further usage of the card will actually will be a mental issue for the customer. Definitely their mind gets disturbed, and then how much money will go, like they started thinking of. For that reason, we have to take immediate action. The second is the continuous data flow. So data arrives continuously without any interruption. For example, weather monitoring stations, or suppose you are having any sensor attached to a reactor which is in Kalpakam. Every now and then from the sensor we get the data. The third is high velocity. Huge amount of data gets generated. Your WhatsApp, your Twitter, your LinkedIn, or your Snapchat, Insta. Huge amount of data per day, per person. Huge amount of data gets, with a fast velocity, right? Large amount of data with the immediate, you post, it gets attached to the app, right? It happens. So that is what high velocity. The time sensitivity, value of data decreases as time passes, especially in terms of stock market. Reliability, the system must process every important data without data loss. So example, hospital monitoring, patient monitoring. The next is scalability. The system should efficiently handle increased data volumes. For example, today I'm from morning I may use my Facebook or Insta and post some messages. The same from tomorrow I may not do. Today, if I post 100 messages, tomorrow I'll post only 1 message. For everything, it's scalable, right? 1 to 100, 100 to 1, person to person varies. If you see the e-commerce platforms during festive times or during Amazon sale times, you see huge amount of transaction happens, right? Sales happens. All this is scale. It should be the system or the technology itself should be scalable. Accuracy. Processing should produce correct results despite high-speed data arrival. Fault tolerance, no fault is acceptable. So the system should not fail at any case. Even if your server fails, there should be a backup and it should start working upon. So these are the 8 characteristics of real-time data. Let us see the use case. Let us assume ourselves, right? We shall put ourselves up here. Right from morning, right? What and all we are doing using our apps. That means you, especially using our devices. We have phones, laptops, or any wearable device. We may actually search for any message, or we may like some post, we may post a message, post a photo, we check emails, we message through using Insta and WhatsApp to our friends, or we may purchase anything through online. If we have a wearable device attached to our wrist so that it captures our heartbeat, our steps, whatever we are walking, our sleep patterns, that all these are captured for one individual. Assume that that's happening for one individual. In terms of real-time scenario applications, if it's a hospital, right, it uses this. What happens further, right? For one individual itself, this means in terms of a hospital, it uses the admission and vitals data to schedule the nurses based on the per day requirement. Transportation system uses vehicle GPS data to cut the congestion. Online store uses browsing data to recommend products. So let us see the use case within our university. So as a faculty, I come to the class, I take the attendance, I upload in the Zoho Creator app. Then similarly, as of now, what I'm doing, I'm just recording a video as a notes for you. If, for example, if any student is in a staying in the hostel, if a parcel comes, they can able to track it out through the courier app API. Then if the student wants to give a feedback about anything, for example, if the facilities available inside the SRM, it is possible. Then a bank's daily transaction. Suppose we have so many banks available in our university. If a student goes and visits, even a faculty goes and visits, everything is getting linked to the data generation, right? Apart from this, there are 4 use cases. The telecom, transportation, connected vehicle, and financial sector. We'll see one by one. These are the I could see major data generators. So the telecom per day, how many people we are calling, right? For example, we talk to our parents, we talk to our friends, etc., and goes on. It may be WhatsApp, it may be the normal phone call, whatsoever. We are doing it out, right? That's called call data records. It captures the voice data and SMS transactions. Geo tracking of the device. If you notice that how quickly you get an SMS if you cross the state border, and how quickly we get a usage alert. For example, 1.5 GB is over, you can get a loan, right? How many people are using prepaid mobile cards, so that you can, if at all your charging tracking system is over, or whether its availability is there, all this are possible by using a telecom or cellular arena applications. These are the major thing where huge data gets generated, and all this can be processed and give an alert or a visualization of the output. Whatever happens inside this can be viewed. The next two is transportation and logistics, where the vehicle data for transportation, logistics, and intelligent traffic management is used. I'll give a scenario where I want to, go for a shipment of an item over the cargo ship, right, over the seas, right, over the sea, right, ocean, the meaning for that. And I want to have a minute-to-minute capture of the temperature of the item. That item is kept inside a box. I want to see or notify the temperature of the item, because my item should not be less than -1 degree. In that case, the item gets collapsed, right, or gets damaged. So every minute to minute I want to get, means that's what is your transportation logistics. Via shipping, right, via traveling, I want to get. So through a communication network, that means through an internet, we can able to capture the minute to minute temperature of the item which gets traveled. The next is connected vehicles. Huge amount of data gets in the near future, not now, as of now, because we don't have that much connected vehicles here. The meaning of that, car to car is able to communicate. One car will communicate to another car, so there's a traffic. One car will communicate to another car, there's ambulance nearby. All this car to car communicate, and automation happens, especially in terms of self-driven cars. Right, this will be a huge amount of data gets generated, and this data which will be very much valuable for the connected cars. And the last one is financial sector. Financial sector is where immediately real-time data is required for yourself to see what amount you can able to put in the stock market, right, for stock exchange or various financial institutions or market prices and fluctuations. If you want to know, you require a real-time data processing tool. So apart from this, some applications have domains and real-time applications have shown here. So banking domain, it is real-time applications, fraud detection. Healthcare, it is patient monitoring. Transportation is GPS navigation. Manufacturing is predictive maintenance. Retail is product recommendation. Social media is live notification. IoT is smart home monitoring. Cybersecurity is threat detection. Smart cities is traffic management. Finance is stock trading. Now we have seen what is the requirement for real-time data processing, how to do it, what is the tools used behind it. The first and the best tool was, till not today, till some years back, this Apache Storm. So Apache Storm is an open source distributed stream processing framework that processes large volumes of data in real time. It was first developed in the year 2011 by Twitter, and for years it was the default choice, but now it's not so. What is the next tool? Is in the next slide I will explain you all. So it introduced concepts such as spouts and bowls. Spouts are nothing but data sources. Bowls are processing units. So making it an excellent tool for understanding the stream processing fundamentals. The features are low latency. As I said, delay is never entertained. No fault is allowed, so fault tolerance. It should be scalable. Per day, I may put one message. Next day, the same person, me itself, I can put 100 messages. So it should be scalable and it should be distributed. The example for distributed, I'll be explaining the next slides. Application is fraud detection, social media analytics, network monitoring. The next tool is Apache Kafka. This is what is the latest tool. If you could see the applications companies use is LinkedIn, Netflix, Uber, Amazon, Walmart, Microsoft, PayPal, Goldman, Airbnb, and Spotify. So this is the event streaming platform. That means the film producer gives the movie to the Netflix, so that will be available in the server, right? So they are the producers. That means the film is given. Now from there we have to view. We are the consumers. Who will stream this one, right? Which is the application which is going to stream this one? That is what is your Apache Kafka. Why such streaming is required? Because Netflix is not used by few customers. Netflix is used by huge number of customers around the world. If you could see in your TVs, Netflix, Amazon are very fast because they use this only. Right? Whereas other applications, for example, Jio Hotstar or your ZTV and all, not that much fast it would be in terms of your, if you want to stop or if you want to move fast forward and all. But in this case, it's very easy because they follow a method called distributed. The same film they'll put into chunks and then they'll store in each of the nodes. Nodes are nothing but computers, and all these computers belong one cluster. So that one movie will be available in one cluster. For example, I'm viewing the movie, that one part will come. Somebody else is moving the movie from the second part. For them, second part will go. So for each of us, there is a separate access fastly we can do. And also, there will be an application called as log aggregation. Suppose if I stop in between, right, I can able to view from that, continue onwards. That log details, where I logged in, where I stopped moving the movie, everything is getting captured. So the features of this Apache Kafka is high throughput, fault tolerant, durable storage, publish, subscribe messaging, subscription we are doing for that one. And applications or log aggregation, as the way I said, everything is captured. Whatever we do as a customer is captured, and where we stopped, from there we can continue. Then data pipelines and event streaming. Similarly, for other applications, for example, if you want to go for micro batch, right, we can use the Apache Spark streaming. So it processes streaming data using micro batches. The features are high-speed analytics, machine learning integration, supports multiple data sources. Applications of financial analytics, IoT, and recommendation systems. All this uses this Apache Spark. Apache Flink is used for high performance. When I say high performance requirements, we'll go for Apache Flink. So features are stateful processing, low latency, event time processing, and applications of fraud detection, sensor analytics, and real-time dashboards. From this onwards, cloud platforms come, right? For example, we have Microsoft Azure Stream Analytics. So obviously, this is a cloud provider. For them, we are going to give a continuous streaming in terms of your data in Microsoft Azure. The features are serverless. Obviously, the server client architecture will not be followed here because there will be a delay. One server is allocated for multiple clients. The server only can manage some amount of clients. Beyond that, it will struggle. So that should be nullified. This concept should be nullified. That's the reason it will be a serverless. Then SQL-like queries, easy cloud integration. Applications are IoT analytics, industrial monitoring, and smart city solutions. Sixth one is Amazon Kinesis. The previous one was actually Microsoft Cloud. Here it is Amazon Cloud. So it uses the AWS managed platform for collecting and analyzing the streaming data. So features are real-time analytics, automatic scaling, integration with AWS services. The next is the Google Cloud Data Flow, where managed service for stream and batch data processing based on Apache Pay. The features are unified processing, automatic scaling, and cloud-native architecture. Let us see the comparison in a nutshell. There are almost 7 tools are there. The first 4, Storm, Kafka, Streaming, and Flink. The developer is Apache. Primary sources for stream processing, event streaming, micro batch processing, event streaming processing. The key features are low latency, fault tolerant, high throughput, scalable, fast analytics, ML integration, stateful processing, low latency. The fifth one is provided by the Microsoft, which is obviously Azure Stream Analytics. So primary process is cloud streaming, and key features are SQL query, Azure integration. The sixth one is also cloud streaming only because it is provided by Amazon AWS services. So it provides the key features of managed service and auto scaling. The last is Google Data Flow provided by the developer Google. So it provides unified stream and batch, and the key feature is Apache Beam support. So let us see the 5-star rating for each of the things. Apache Kafka, Apache Flink, Apache Spark, Databricks, Azure Event, and then Delta Live Tables have a 5-star rating, and based on their industry usage, excellent, easy, very good, medium. I've just noted down here. Now, so how to implement this one? I want to stream, right? I have to do that. Before that, the requirements are you have to install definitely Java JDK 17 plus, then Apache Kafka, or you can go for Flint whatsoever, but Apache Kafka is the best option. Then Python 3.11 version plus, because beyond that only it will be supportable. VS Code, Docker Desktop, that's for making the containers. And then Streamlit, Pandas, NumPy, Scikit-learn, and GitHub. Now, I have taught you what is real-time data processing, what are the tools used for real-time data processing, what we can do with that, right? So we can do, these are the projects, real-time vehicle tracking system we can implement, smart traffic monitoring we can implement, live weather dashboard we can do, banking fraud detection we can do, smart agriculture monitoring, air quality monitoring, industrial mission failure prediction, live Twitter or X, whatsoever, it can be LinkedIn or it can be Facebook, all the sentimental analysis we can perform. Then hospital patient monitoring and smart energy meter analytics, right? So these are the major projects we can do. So in a nutshell, I have given the introduction about what is real-time processing, and then what are the tools used for real-time processing, and what are the best projects you can make out of it. I have given it out. So I've covered the first 4 topics of Unit 1 in this video. So the second unit I will be covering the next video, which is on big data. Thank you all.